Okay, right. In this lecture, we'll cover a Signum function and its graph. Okay, this is how we define Signum function. So, Signum of x is defined as modulus of x divided by x when this x is not 0, and this value is defined as 0 when x is 0. Obviously, you cannot find a value of mod x by x at x equals 0. This is how we define Signum function. Okay, so if you expand this function when x is positive, this mod of x is x by x, so plus 1. If x is negative, mod of x is, to make it positive, minus x, and then divided by x, which is minus 1. So this is the definition, and it's a convenient one, which means this value is plus 1 whenever this number is positive, minus 1 whenever this value is negative, and 0 whenever this x is 0. Okay, suppose we wish to calculate Signum of x square. Now x square, this value will be plus 1 whenever x square, this x square is positive, value is 0 whenever x is 0, and negative whenever x square is negative. So this third possibility doesn't really exist in this case. X square is either 0, like if you draw graph of x square, okay, this is x square, so either greater than equals positive or 0. So exact whenever x is 0, so this Signum of x square is 0 and x not 0, which means x square is positive, hence value is 1. Suppose Signum of 1 plus x square, which means this is 1 plus x square, 0 comma 1. So itself 1, because this possibility, now minimum value of this function is 1, which means this value is always positive, 1 plus x square. So Signum of 1 plus x square is 1. Likewise, Signum of x square plus x plus 1, it's a very beautiful expression. X square plus x plus 1 greater than equals 3 by 4, and roots are omega and omega square, right? Which means again this value is constant and 1. Suppose Signum of x minus 1. Either you can do it in a very proper way if you are not confident enough to deal this situation right now, or if this value x minus 1 is positive, which means x is greater than 1, so value is 1. If x is greater than 1, so Signum of this will return 1. If x equals 1, then 0, otherwise minus 1. Okay, good. Next part, Signum of sin x. Signum of sin x, which means mod of sin x divided by sin x. I'll write it here. Either Signum of sin x, which means sin x divided by sin x when sin x is not 0, and 0 when sin x is 0, right? Sin x is 0 at n pi, so n pi is very convenient to deal with. Now sin x could be positive or negative. Sin x is positive in first quadrant, which means positive value divided by sin x, so plus 1. Whenever sin x is negative, which means third quadrant and fourth quadrant, then this value will return positive, and this is negative, which means minus 1. So this is the kind of graph. We'll be having exact zeros whenever sin x is 0, which means n pi. So at x equals 0, value is 0, at x equals pi is 0, 2 pi is 0, 3 pi, 4 pi, minus pi, so on. Now whenever sin x is positive, which means first quadrant and second quadrant, so 0 to pi, between 0 to pi, this Signum of sin x will return plus 1, right? And I represent, like, this value will be selected and we need to refuse this one, so I prefer these arrows. Whenever you want to exclude values, I don't use that empty space, I use arrows. So this value will be neglected, this is selected. Okay, so arrows means refusal. So between 0 to pi, y coordinate is 1, endpoints excluded. Pi to 2 pi, which means third quadrant and fourth quadrant, sin x will be negative, so minus 1. And because period is, sin x is periodic and period is 2 pi, so you can do the rest. You keep on repeating it. this value will be plus 1. Like this is minus 1, which minus 1, 1, 1. Now next is signum of log x, which means this value is plus 1. Now I'll do it directly. Whenever log x is positive, 0. When log x is 0, minus 1, log x is negative. This is the graph of log x. When log x is 0, which means x equals 1. So at x equals 1, signum of log x is 0. When log x is positive, which means this part. So beyond this. So when x greater than 1, then signum of log x will return 1, and between these values 0 to 1, log x is negative, which means minus 1, right? So if you want to draw graph of signum log x, so this 0, 1, and then minus 1, 0 is excluded, right? And these 4 questions are for you as practice. Okay, this was signum function, and I suppose there is nothing much to talk about, right? Okay.